Solve. So for example A, we have 3 to the x is equal to 5. So we used to try to find the common base for both sides of the equation when working with exponential equations, but we're not going to be able to get a common base for 3 and 5. Both of those numbers are prime. There's nothing we can really do to make them have the same base. So when that happens, you might want to apply a trick of taking the logs of both sides of the equation. Now, we can take ln, the natural log of both sides of the equation. We can take the common log of both sides of the equation. We could take log base 7 of both sides of the equation. But generally speaking, you pick the one that you're most comfortable with, or in some particular situations, there might be an advantage to choosing one or the other. For example, if you have e's in the equation, you should probably use the natural log. If you have tens in the equation, then you might want to use the common log because it has base 10. Those kind of tricks are available as well. But for the most part, we're going to use the natural log most of the time, mainly because it's just simple to write, right? So for example, we can do ln of 3x is equal to ln of 5. So we're taking the logs of both sides of the equation. This is okay as long as we do it to both sides. And then what's going to happen is this x is going to come down in front as a result. So we're going to end up having x times ln of 3 is equal to ln of 5. Remember, that's a property of the logs, which says that if you have an exponent on the thing you're taking the log of, you can pull that thing down in front and make it the coefficient of the logarithm. So we end up with x times ln of 3 is equal to ln of 5. Remember, ln of 3 is just a number, right? So we can certainly just divide both sides by ln of 3 to isolate x. And when we're done, we have our answer for x. X is equal to ln of 5 over ln of 3. You can use a calculator to approximate that if you'd like, but I'm just going to leave it as an exact answer, ln of 5 divided by ln of 3. All right, let's look at example B then. For example B, it's very similar. Again, we cannot get a common base here, so we're just going to take the ln of both sides. So I'll do the ln of 2 to the negative x is equal to ln of 1.8. Again, that negative x can come out in front here to make negative x times ln of 2 is equal to the ln of 1.8. And then we can divide both sides of the equation by negative ln of 2. If we do that on the right-hand side, we'll get negative ln of 2 in the denominator. The negative will cancel out with the negative. The ln of 2 will cancel out with the ln of 2. And we'll have x is equal to ln of 1.8 divided by negative ln of 2. And again, you can approximate that if you'd like with your calculator, but there's the exact answer. All right, let's work out examples C and D then. For example C, we'd want to first perhaps divide off this decimal, right? Because we want to isolate x on one side of the equation, so it might be useful to divide both sides by 0.9 to start. All right, so we divide that off. You're going to end up with 4 to the 0.3x power is equal to, now 0.6 over 0.9 is the same as 6 over 9, and that's the same as 2/3. So we can rewrite that as just 2/3. So we'll have 4 to the 0.3x power is equal to 2/3. Okay, from there, again, we cannot get 4 to be in the same base as 2/3, so we can just simply, if we want, take the ln of both sides. So it'll be ln of 4 to the 0.3x power is equal to ln of 2/3. Then from here, we can bring down this piece here. So we'll end up having the exponent come forward as a coefficient. It'll be 0.3x times the ln of 4 is equal to, I like to write fractions as a difference. So I like to say ln of 2 here minus ln of 3. Remember, you're able to do that, right? So a quotient can become the difference of two logs. So basically I'm writing ln of 2/3 as ln of 2 minus ln of 3. I just like that better. I think it looks cleaner. You don't have to do that, but if you want to, that's how it would be done. And then to isolate x here, we would divide basically 0.3 times the ln of 4 to both sides of the equation, right? 0.3 ln of 4. And then that would cancel out here and here, cancel out here and here, leaving you simply that x is equal to ln of 2 minus ln of 3 over 0.3 ln of 4, and that again can be evaluated with a calculator to get a decimal approximation, but the exact answer is there. All right, so the final example is example D. If we look at example D, again, it's not possible to rewrite 5 and 2 so they have the common base or the same base. So we're just going to take the ln of both sides. So I'll do ln of 5 to the 1 minus x power is equal to ln of 2 to the x power here. I can bring down these exponents as coefficients. So I have 1 minus x times ln of 5 is equal to x, right? Because that'll come out in front as well, ln of 2. Now from here I'll have to distribute because I want to get the x away from that 1. The only way to do that is to distribute in the ln of 5. So ln of 5 times 1 is ln of 5. ln of 5 times negative x is negative x times ln of 5 is equal to x times ln of 2. All right, now we want to get the x's together on one side of the equation, so I'll move the x over here, making it positive. So I'll end up having ln of 5 on the left-hand side. On the right-hand side, I'll have x times ln of 2 plus x times ln of 5. So remember, when that negative x ln of 5 cross the equal sign, it becomes positive. Then we factor out the x, right? That's common to both pieces. So I'll end up with ln of 2 plus ln of 5, right? Pulling out that common x. And that's equal to ln of 5. And finally, to isolate x, we divide both sides by ln of 2 plus ln of 5. So ln of 2 plus ln of 5 on the other side. And that's our answer for x. Ln of 5 divided by ln of 2 plus ln of 5. You could, by the way, if you wanted to combine this into a simpler statement, you could say ln of 5 over, remember that a sum can be written as a product, so it would just be ln of 10. So if you wanted to do that, you could do that. That's also the same thing, but it doesn't make much of a difference. It's just an extra calculator stroke saved if you're going to evaluate it in the calculator.